Hello everyone, my name is Eric Small. I'm the Senior Medical Animator at Mad Microbe Studios. Today I'm going to do a breakdown of the social media post that we did a while back about alveoli breathing. I'm going to show how I use dynamics to make the alveoli move, and then show how I took those dynamics and made them loopable. To get started, I create a sphere and set it to the icosahedron mode, and I'm going to reduce the size a little bit. Next, we're going to add a displacer deformer as a child of the sphere, and we'll add a noise pattern to the shader. We'll quickly adjust the Phong shading on the sphere, and then we'll go back into the noise pattern. We will increase the scale. Then I'm going to take that sphere and I'm going to place it as a child of a cloner. And in grid array, we're going to make it, increase it in the Y and decrease it in the X and Z. Then we'll adjust the spacing a little bit until we get it to be just not quite intersecting with one another. Next, we'll apply a random effector to the cloner, and we'll adjust the position, and we'll also add some randomness to the rotation to make it look a little bit more organic. We can also add just a touch of scale as well. Now, if we're not happy with how everything is being placed, we can adjust the seed value of the random effector, and this will just change up how the spheres are being distributed. Next, put a push apart effector into the scene, and we'll get these spheres so they're close, but not quite touching one another. I think I'm going to increase the sphere size too, just a little bit. But eventually, once we get it close, I'm just going to right-click and current state to object this cloner. Then what that gives me is all of these spheres as baked down geometry. Next, then, what I'm going to do is I'm going to actually just go in and I'm going to noodle these around, push them around in space so they kind of clump together like they would be in a cluster of alveoli. Once we're happy with all of the spheres in place forming the cluster of alveoli, we can delete our setup cloner and continue on with our build. The next thing we want to do is we want to try to get these spheres looking like they're squished in together. So what I'm going to do here is I'm going to take the topmost null of all of the spheres, and I'm going to have that selected and create an instance. Essentially what this is going to do is it's going to create a copy of the spheres. Now I'm going to create a volume builder, and I'm going to place it as a parent of the original hierarchy of spheres that we had current state to object. I'm going to tighten that up a little bit and reduce the voxel size to 5. Now I'm going to create a smoothing deformer and make sure it is a child of the instance that we created of all of these spheres. And we're going to drop the stiffness down to 0 and make sure the strength is working correctly. And we see that it's smoothing all of the spheres. Now we don't want that, we just want it where they're intersecting. So what I'm going to do is I'm going to grab the volume builder that we just created and drop it in as a field. And we see that not much is happening at the moment. That's because next thing we got to do is we got to add in a range mapper. And we need to turn the max object output to -100. If we zoom in here, we see that where they were intersecting with one another, now they're puckering up like they were soft bodies that had just collided with one another. Now we can add a subdivision surface to this. And we see that it starts to smooth out the entire cluster of alveoli. I'm going to turn down the subdivision surfaces from 2 to 1 because we don't need it quite that dense in geometry yet. And at this point then I'm going to current state to object the subdivision surface and bake down this geometry. And from there then I'm going to delete out all of the stuff that we'd used as a setup. The volume builder, the instance, the smoothing, all of that because we're done with it at this point. Now, all of these, after they've been baked down, are individual pieces of geometry and separate objects. What I want to do is I want to select them all, and I want to connect and delete, because I want all of these to be one object. Then we'll rename it alveoli cluster. Now, I want to put this through a smoothing deformer one last time, just to smooth it out a bit more. And once we do that, and we've got that where we like it, we're going to current state to object one last time, baking this down into its smooth yet slightly deformed state. And then we can delete out everything that we did to this point, so we just have this slightly displaced but smooth out cluster of alveoli. Now, if we look at the mesh of this object, we see that we have a lot of triangles, clean mesh. So I'm going to run this through the Cinema 4D's remesher, search for it, make it apparent, and give it a moment. I'm going to use the Z remesher algorithm, and we see that now everything is really nice quads. I'm going to reduce the mesh density, because ultimately this is going to be something that we're going to animate with dynamics, so I don't want this too dense. And once I'm happy with this, I'm going to current state to object. And then one more time, we can delete out the original one. So now we have that same shape that we just had previously, but with a much cleaner, much lower density mesh. Now at this point, we pretty much have our cluster of alveoli ready to go. So we're going to turn our focus onto creating the vasculature that surrounds it. I'm going to show two ways of doing this. One is going to be a procedural way, and one is going to be a much more manual way. But no matter which way we go with, I want to create essentially a skin around this alveoli. So in order to do that, I'm going to make a copy of it, and I'm going to create a volume builder and then a volume mesher. I'm going to reduce the volume builder down in voxel size to about 5. I'm going to add in a dilate and erode to kind of puff it up, and then I'm going to add a smooth on top of that. And now you see as we click the original alveoli cluster here, we see that it is kind of tucked inside of this perfectly skinned shrink wrap. If we look at the mesh here, it's really dense, it's really rough, it's not really a nice mesh. So we're going to run that through the remesher one more time. I guess first time for this one. I'm going to reduce the mesh density down. Give it a moment to calculate here. And now you see we have this shrink wrap around the alveoli cluster that has a really nice mesh to it. Change the name on it. And going to, again, current state to object, and then delete out the setup. And I keep doing this by deleting out what we had just created, just to keep the scene as lightweight as possible. To make the vasculature in a procedural way, I'm going to click that skin of the alveoli cluster that we just created, the alveoli shape, and I'm going to make a Voronoi fracture apparent of that object. I'm going to offset the fragments a little bit by about 4.5, maybe 4 centimeters. Next, I'm going to invert it, turn on hull only, and you see that we start to get this shape of vasculature almost kind of just across the surface. We can increase the point count, and we can adjust the seed value until we're getting kind of a nice organic shape that we're liking. And here we have the start of our vasculature. Once we're happy with the shape overall, we can add a remesh, so we get a nice clean mesh going along the surface. We can reduce that down a bit. And next, we are going to thicken it up by adding a thicken generator. And from here, we can add a subdivision surface to smooth it out. And you see that we're starting to get a really nice vasculature going along the surface. Now, it's not perfect. We do have some gaps in here, but we can change that, or we can fix that by adjusting the seed value and the point amount, and ultimately by adjusting the remesh and how aggressively we're trying to reduce the mesh density on that generator. Now, it works. It's not perfect. And it's not very art directable. We can further reduce that clipping by adjusting the amount of offset, and essentially by thickening up the fragments. But again, this is a procedural way that you can generate this vasculature along the surface. Um, Again, it works, but it's very hard to make it look super organic. So what I did is I grabbed the spline sketch tool and I activated snapping. And in the snapping, I turned off the point, but I turned on polygon. So now as I sketch across the surface here, the spline will snap to the polygon surface. I just started at the top and started sketching my way down and getting the vessels, or the splines that will be vessels, to branch and just look nice and organic wherever I wanted them to be. Now, I'm being careful here and thinking ahead where I'm drawing these, because I know that I'm going to be working with dynamics ultimately, especially soft bodies, and I'm going to ultimately use the vasculature as a cage to contain the soft body spheres, or the alveoli. Now, by the power of movie magic, I have finished drawing all of my splines. And one thing that I want to point out here is that I did not show in the actual recording is I used this resample spline in order to redistribute all of the points along the spline. And you can find that in the asset browser just by typing in resample. Now that we have our spline completely wrapped around our alveoli cluster here, the most logical way to get the vasculature would be to sweep it. And we can do that by creating a sweep, and we'll make then the profile a sibling of the spline as a circle. We'll reduce its size and thicken it up, and there we go. But the issue that we have is that none of these splines actually connect with one another. They terminate before they can actually join. So doing the sweep is not the best approach. So instead, I'll take that back out of the sweep, and we're going to current state to object just so we have those points evenly distributed along, and we're going to switch to cubic type of spline with uniform point intermediate points. And I'm going to make this into a volume. So I'm going to make a builder and then a mesher, and we're going to reduce the voxel size. We start to see our mesh is starting to get kind of dense again, but it's fine. We can always change that up with the remesher. Now I'm going to click on the actual spline in the field here, and I'm going to reduce its radius down. And we see that it's starting to get a little sparse. So I'm just going to increase the density of that spline until it gets nice and smooth. And it's a matter of just twirling these numbers until we get something that we are starting to like. I think this is starting to look good, so I'm going to add a dilate and a road to it. And I want this to be a little bit thicker at the top where the vasculature ultimately comes in and starts to branch. I'm going to use the linear field to control that thickening where it's thickening and thinning. Just adjust that until it's looking nice. And from there, I want to add a smooth to it. Now, this is getting a little aggressive with it, so we're going to reduce the voxel distance and also the strength. And as we rotate around, we can see that this is smoothing and looking pretty good from most angles. I think we're ready to go. So when we're happy with this, we're going to go into add a remesh. And I already know that this is going to be really dense, so I'm going to drop this way down. Let's go 26% or so. Give it a moment to calculate. And there we go. That's a pretty good density, I think, for animating with dynamics. Some quick housekeeping items to attend here. Renaming and regrouping our objects within our scene, just to keep things clean. Now we're going to turn our attention to modeling the bronchial and the musculature around it. To start, I'm just going to add a cylinder to the scene, and this is going to be our bronchial. So I'm going to scale it down, make it a little bit narrower, and place it. We have no need for the caps, so we can turn those off and just get it in place exactly where we need it to be. Now for the musculature, I'm going to start with a spline. And I'm going to place this as a child of the cylinder just so we can make sure that it is exactly in the middle. Zero that out. We're going to make it a bit narrower just so it fits in between the vasculature that we created already. narrow up the bronchial just a touch more here. Now back to our spline, I'm going to first create an instance of this circle spline. And then back on the actual spline, I am going to make a displacer, a child of it. And in the shading, I'm going to add a noise pattern. But you see immediately here, we have a bit of a problem in that the noise pattern is making the spline just go any which direction because it's based on the normal direction. So if we go into the Object tab and we set it to planar, I want this displacer to deform the spline up and down in the Y direction. Now back into the shader, going to increase the scale until we get this nice, subtle, gradual undulation. Now, if we go back to the circle instance that we created, we see that the circle instance is the exact same shape as what the actual spline that we are deforming it is. And so if we loft the two of those together, we start to get this band, this deformed cylinder, that kind of looks like musculature that's wrapping around the bronchial. Next, we're going to take that single band of musculature, and we're going to clone it and change it to linear mode. And we can change the count, and we're going to decrease the distance in the Y that these are being spaced out. Now they're being repeated perfectly, and we can definitely see a pattern, which is not what we want. So I'm going to add a random effector to it. I'm going to change their distance that they are offset in the Y, and then adjust the seed value a little bit so we're getting something that we like. And then let's also go into the rotation, and we'll change that up, just kind of drag this up until we get something that we're liking. Maybe adjust the spacing a little bit. Now we're starting to get the actual musculature bands that we would see. Now, these are still separate objects at the moment. And when we render this, we're going to see that they are indeed separate objects. We'll see that they're clipping into one another. Just go in and change a couple more objects here. There we go. Now, in order to make sure that these don't look like they are separate objects, we're going to put these into a volume builder and a volume mesher. We're going to decrease our voxel size, smooth it out a little bit, reduce the strength of that smoothing, and now we're starting to see this nice, smooth band of musculature wrapping around this bronchial. I think I'm going to add one more to this, and once we're happy with the overall shape and look, we can go and add ourselves a remesher. I'm going to drop the mesh density, and now we have nice clean mesh for the bronchial musculature. Now we're going to move on to animation. What I've done at this point is I have taken everything that I've created and baked it down to 3 separate objects. We have the vasculature, we have the alveoli cluster, and then we have the bronchial and musculature. All geometry has been current state to objected, so there's no more generators, no more volume builders, meshers, or anything like that, no more cloners. It's just all geometry. And we're doing this because we want to keep the scene as lightweight as possible because we're going to start animating with dynamics. I'm going to start by adding a simulation tag to the alveoli cluster. Now, I'm not going to use actual soft bodies. I'm going to use the balloon tag. And I'm doing this just because this is a little bit lighter weight than the actual soft bodies, and we don't need all of the calculation intensity of the soft body to create the effect that we're after. So if we immediately press play, we see that the alveoli cluster falls down. What we need to do is we need to go into our scene settings, into simulation, and in the scene tab, we need to change the gravity to 0. We don't want these falling, we just want these staying in place. And we see that they immediately start to undulate because they're clipping ever so slightly with each other. Not a problem, this is a perfect start. What we need to do is we need to adjust some settings in the balloon parameter. We want the alveoli to inflate, and we do that by changing the overpressure from 1 to 2. So what we want to do is we want to keyframe this value. So at frame 0, we're going to set another keyframe to 1. We're going to jump ahead, and at 1 second, we're going to set our keyframe to 2. And at the end of our scene, we're going to set the pressure back to 1. So these should inflate and then start to deflate. Now, it's not going to be a perfectly looped simulation because it is, after all, a simulation. But this is a really good start. But they're not really respecting the vasculature. As they inflate, they just kind of push through, they clip through because they're not being seen. That vasculature is not being seen. So what we can do is we can add a collider tag to the vasculature. Now, when it inflates, there we go. We see that they are respecting the vasculature, and they're kind of pushing their way around. They've got that nice soft body, that balloon-like look. However, the vasculature is not this perfectly solid, rigid structure. It's going to move with the alveoli because, after all, it is tissue. It is a single layer of cells. So what we want to do is we want to delete this collider tag, and instead we want to add a balloon tag to the vasculature. Now, as we play, we see that the alveoli are pushing the vasculature outwards. Now, it's working, but we're losing that nice deformation of the alveoli squeezing around the vasculature. And the vasculature itself is moving far too much for what it should be doing. Well, we can fix this by just ticking the with force option in the Mix Animation tab. And here at this point, if we go in, we start to see that this is really starting to work nicely now. And if we reduce the strength from 1 down to 0.1, we see that we can control how much influence the pushing out alveoli have against the vasculature. So if we dial this strength up, we start to see that we get the vasculature moving ever so nicely, but the alveoli are also pushing out and bulging out around it, exactly what we're after. We can go into the balloon tag on the alveoli, and we can adjust some of the surface parameters. We can increase the bendiness, and we can increase the stretchiness. And we start to see now that we're getting a little bit better deformation of the alveoli. At this point, we're also going to adjust the same parameters on the vasculature, but we don't want the vasculature to be quite as stretchy or bendy. So we're going to set those values a little bit lower. And at this point, it's a matter of guess and check. You're just going to keep going through and adjusting parameters until you get the overall look and feel that you're after. There's no right or wrong. It's just a matter of what ultimately aesthetic are you after. This is why working with dynamics can be so difficult from time to time. And sometimes if you have the ability to work with deformers or just keyframe animation, you can do things so much more efficiently. Now, once we have all of the parameters dialed in, it's time to cache the simulation. And we do that by selecting both of the balloon tags, going to the Cache tab, and pressing Cache Scene. Now, we can scrub the playhead back and forth, and we see that the dynamics are perfectly cached. We don't have to worry about playback and everything being calculated live. This gets us to a good point, but ultimately we want to loop this animation. We want this to be seamlessly looped. And if we look at our first frame and our last frame, we can definitely see that they are not the same. So to do this, what I'm going to do is I'm going to duplicate the vasculature and the alveoli, and I'm going to change their name to and add a DEF at the end for these are going to be deformed. I'm going to go to the balloon tags, and I'm going to delete these off. So now we've just got these static objects. There's no animation to them. There's no movement as we scrub through. We don't see anything. What I'm going to do is I'm going to grab a surface deformer and make sure that it is a child of the alveoli cluster DEF model, because this is going to be the one that is deformed. And to drive that, I'm going to go over and I'm going to grab the dynamic alveoli cluster and drop it into the surface. and then I'm going to click Initialize. And now you see that we have the deformed version that is following exactly the way that the cached dynamic version is. So how do we loop this? Well, we see that we've got a strength slider in the deformer. So what we do is we keyframe that at 0, then we set a keyframe at 1 second to 100%, and then at the very end we set that keyframe back down to 0% strength. And now we see that the start and end frame are exactly the same. But we still have that beautiful dynamic animation that we had previously from the dynamic version. And I can even overcrank this value a little bit if I want, just if I want to get a little bit more deformation, just a little bit more emphasis on that inflation of the alveoli. Now we can do the exact same thing with the vasculature. Create a surface deformer as a child. And I'm going to drag in the dynamic vasculature that is cached into the surface object of that surface deformer, and then we'll click Initialize. Now, there's one issue with using the vasculature, and we can see it by turning off the alveoli cluster here, and we see that as this animates, the vasculature actually gets thinner, or the lumen of the vessel would be getting narrower, and that would be a very bad thing in real life, because that would be restricting blood flow as your alveoli increase. And that's no good. So instead of using the vasculature to drive the deformation, I'm going to just delete that off and create a new one. And in this case, I'm going to drag in the alveoli cluster that's cached. Click Initialize, and we see that that is starting to deform without pinching the lumen of the vessel. Now, it's a little wonky at the moment, but we're going to fix that up here shortly. First things first, I'm going to set my keyframes like I did for the alveoli cluster. 0% at 0, 100% at 1 second, and then back to 0 at the end of the clip. Now we see this craziness with the vasculature up at top. So what we're going to do is we're just going to restrict this surface deformer's influence by using a linear field. And we'll set it in the negative y direction, and we'll place it just so that its influence is starting to happen below the vasculature that's coming into the alveoli cluster. Now let's turn our attention to this weird clipping geometry we've got going on down here. Well, that's something that we can fix by just adding a smoothing deformer after the surface deformer. And now, as we scrub through, we see that we have a perfectly deformed alveoli cluster and vasculature, and it is perfectly looped. So there you have it. That is a breakdown of how I set up and animated this loopable dynamic alveoli cluster. Thanks for watching.